Have you ever wondered what your brain is actually doing when you're not actively pursuing anything? When you're just lying there, staring at the ceiling or gazing out a window, lost in thought? Most people assume the brain powers down during these moments, that it enters some kind of idle state, conserving energy until the next challenge arrives. But neuroscience reveals something far more fascinating and counterintuitive. Your brain, in these supposedly quiet moments, is anything but quiet. In fact, it's consuming nearly as much energy as it does when you're intensely focused on a complex task. This discovery has revolutionized our understanding of how the brain functions and has opened up entirely new fields of research into what's called the default mode network, a system that becomes more active precisely when you're not actively engaged with the external world. Let's start with the energy consumption puzzle that first alerted scientists to something unusual happening in the resting brain. The human brain, despite representing only about 2% of body weight, consumes roughly 20% of the body's total energy expenditure. That's an enormous metabolic cost for a single organ. What's even more surprising is that when neuroscientists began measuring brain activity during various tasks using techniques like functional magnetic resonance imaging, they discovered that demanding cognitive tasks only increased the brain's energy consumption by about 5% above baseline. Think about that for a moment. Whether you're solving complex mathematical equations, learning a new language, or simply daydreaming, your brain is using nearly the same amount of energy. This observation led to a fundamental question that would reshape neuroscience. What is the brain doing with all that energy when we're supposedly doing nothing? For decades, neuroscience research focused almost exclusively on task-related brain activity. Scientists would ask participants to perform specific cognitive tasks while measuring their brain activity, looking for regions that lit up in response to these challenges. This approach made intuitive sense. If you want to understand how the brain processes visual information, show people images. If you want to understand language processing, have them read or listen to words. But this task-focused approach had a blind spot. Researchers treated the brain's baseline activity as mere noise, something to be subtracted away to reveal the signal they were actually interested in. It was like studying the ocean by only looking at the waves created by passing boats, completely ignoring the vast currents flowing beneath the surface. The paradigm shift began in the early 2000s when neuroscientist Marcus Rachel and his colleagues started paying attention to what they had been throwing away. Instead of discarding the baseline activity, they began examining it carefully. What they discovered was astonishing. When people weren't engaged in specific tasks, when they were just resting with their eyes closed or staring at a fixation point, certain brain regions consistently showed increased activity. Moreover, these regions were remarkably consistent across different people and different resting conditions. This wasn't random noise at all. It was a coherent, organized pattern of brain activity that appeared specifically when people weren't focused on the external world. Rachel called this the default mode network, the mode your brain defaults to when it's not otherwise occupied. The default mode network includes several key brain regions that show synchronized activity during rest. The most prominent is the medial prefrontal cortex, located at the front and center of your brain, just behind your forehead. This region is involved in thinking about yourself, your preferences, your personality traits, your social standing. Then there's the posterior cingulate cortex, an adjacent precuneus located deeper in the brain along the midline. These areas are associated with retrieving memories and imagining future scenarios. The lateral parietal cortex, on both sides of the brain, contributes to attention and processing spatial relationships. And finally, the medial temporal lobes, which house the hippocampus, are critical for memory formation and retrieval. These regions don't work in isolation. They form an interconnected network, constantly communicating with each other through synchronized neural oscillations, creating a sort of brain-wide conversation that occurs specifically when you're not engaged with immediate tasks. But what exactly are these regions doing when they're active together? This question has driven thousands of research studies over the past 2 decades, and the answers are both profound and somewhat unsettling. The default mode network appears to be the neurological basis for what we might call the narrative self, the ongoing story you tell yourself about who you are, where you've been, and where you're going. When this network is active, your brain is engaged in what researchers call self-referential processing. You're thinking about yourself, your relationships, your past experiences, your future possibilities. You're mind-wandering but not randomly. Your thoughts tend to cluster around autobiographical memories, social interactions, planning for the future, and evaluating your own mental states. One of the most compelling pieces of evidence for this interpretation comes from studies that combine brain imaging with experience sampling. Researchers will scan people's brains while periodically asking them what they're thinking about. When people report that their minds have wandered from the task at hand, when they're thinking about personal memories or future plans or social relationships, the default mode network shows increased activity. Conversely, when people are intensely focused on an external task, activity in the default mode network decreases. It's as if the brain has two modes of operation, one oriented toward the external world and immediate tasks, and another oriented inward, toward the self and its place in time and social space. This discovery has profound implications for understanding consciousness itself. The default mode network may be the neural correlate of what philosophers call the phenomenal self, the subjective sense of being someone, of having a continuous identity that persists through time. When you say, I, when you feel like there's a unified agent inhabiting your body and experiencing your life, that feeling appears to emerge from the coordinated activity of the default mode network. This isn't just philosophical speculation. Damage to key nodes in the default mode network can profoundly alter people's sense of self. Patients with lesions in the medial prefrontal cortex, for example, often show reduced ability to think about their own mental states or to understand that other people have different perspectives from their own. The network that becomes active in the absence of goals appears to be the very foundation of selfhood. But the default mode network doesn't just maintain your sense of self. It also serves several crucial cognitive functions that require you to temporarily disengage from the present moment. Consider memory consolidation, the process by which short-term memories are transformed into long-term storage. This process doesn't happen in real time as events unfold. Instead, it occurs later, during periods of rest, particularly during sleep but also during wakeful rest. Studies have shown that patterns of neural activity recorded during a learning experience are replayed in the hippocampus during subsequent rest periods. And this replay is coordinated with activity in other parts of the default mode network. Your brain is literally rehearsing experiences, transferring them from temporary to permanent storage. And this critical process happens precisely when you're not actively engaged with new information. The default mode network is also essential for simulation, the ability to imagine scenarios that aren't currently happening. This capacity is fundamental to human cognition. When you plan for tomorrow, you're simulating future scenarios. When you try to understand someone else's perspective, you're simulating their mental state. When you replay a past conversation and think of what you should have said, you're simulating an alternative past. All of these simulations require you to decouple from the present moment and construct mental scenarios that exist only in your imagination. Brain imaging studies consistently show that the default mode network activates during these kinds of simulations. The same regions that activate when you remember your actual past also activate when you imagine possible futures or construct hypothetical scenarios. In fact, researchers have found it difficult to distinguish brain activity during memory retrieval from brain activity during future imagination. They recruit such similar neural networks. This simulation capacity has obvious evolutionary value. An organism that can mentally rehearse different scenarios and predict their outcomes has a significant advantage over one that must learn everything through direct trial and error. Mental time travel, the ability to mentally project yourself into the past or future, allows you to learn from experiences you haven't had and prepare for situations you haven't encountered. The default mode network, active in the absence of immediate goals, may be the neural machinery that allows humans to transcend the present moment and inhabit other times and places mentally. The network also plays a crucial role in social cognition, understanding other people's mental states, intentions, beliefs, and feelings. This ability, sometimes called theory of mind or mentalizing, is essential for navigating the complex social world that humans inhabit. When you try to figure out why your colleague seemed annoyed, when you wonder what your friend is thinking, when you predict how someone will react to news you're about to share, you're engaging in social cognition. These processes consistently activate the default mode network, particularly the medial prefrontal cortex and temporal parietal junction. Interestingly, thinking about other people and thinking about yourself activate remarkably overlapping brain regions, which has led some researchers to propose that we understand others by using ourselves as a model, by simulating what we would think or feel in their situation. The discovery of the default mode network has also shed light on various psychological disorders. Depression, for example, is associated with altered activity in the default mode network, particularly increased rumination. The tendency to repetitively focus on negative aspects of oneself and one's experiences. Brain imaging studies show that people with depression often have hyperactive default mode networks that they struggle to suppress even when trying to focus on external tasks. This persistent self-focus, when it takes a negative form, can create and maintain depressive thought patterns. The network that normally supports adaptive self-reflection and planning can, when dysregulated, trap people in cycles of negative thinking. Anxiety disorders also show altered default mode network function, but in somewhat different ways. People with generalized anxiety disorder often show excessive activity in parts of the default mode network associated with imagining future scenarios, but these simulations take a catastrophic turn. Instead of adaptively preparing for realistic possibilities, anxious individuals mentally rehearse worst-case scenarios, creating detailed simulations of terrible things that might happen. The same neural machinery that allows adaptive planning can produce maladaptive worry when it becomes focused on threat and uncontrollable by normal regulatory processes. Autism spectrum disorders present yet another pattern of altered default mode function. Many individuals with autism show reduced connectivity within the default mode network, particularly in regions associated with social cognition and theory of mind. This finding aligns with the social difficulties characteristic of autism and suggests that the spontaneous mental activity that typically occurs during rest may be qualitatively different in autism. Some researchers have proposed that the reduced default mode connectivity might relate to differences in self-referential processing and social understanding that characterize the autistic experience. Alzheimer's disease was one of the first conditions linked to default mode network dysfunction. Years before the discovery of the default mode network, researchers had noticed that Alzheimer's pathology, the accumulation of amyloid plaques and tau tangles that characterize the disease, showed a distinctive spatial pattern. The regions affected earliest and most severely were precisely those that would later be identified as core nodes of the default mode network. This isn't a coincidence. The high metabolic activity of the default mode network during rest may make these regions particularly vulnerable to the processes that drive Alzheimer's pathology. Moreover, disruption of this network may explain some of the cognitive symptoms of early Alzheimer's, particularly difficulties with episodic memory and disorientation in time and space. Understanding the default mode network has also transformed our understanding of meditation practices. Mindfulness meditation, which emphasizes present moment awareness and non-judgmental observation of mental content, appears to systematically reduce activity in the default mode network, particularly in regions associated with self-referential processing. Experienced meditators show less baseline activity in these regions and are better able to regulate default mode activity. This finding provides a neurological explanation for the subjective reports of meditators who describe a quieting of the constant narrative self-talk, a reduction in the sense of separation between self and world, and a greater focus on immediate sensory experience. Meditation may literally be training people to reduce the dominance of default mode processing and spend more time in present moment awareness. But the relationship between the default mode network and external attention isn't simply antagonistic. More recent research has revealed a complex dynamic interplay between what researchers call the task-positive network, regions that activate during goal-directed tasks, and the default mode network. These networks don't just trade off, with one turning on while the other turns off. Instead, they engage in a coordinated dance, with flexible coupling and decoupling depending on the cognitive demands of the moment. The ability to smoothly transition between these modes, to engage with external tasks when needed, and then shift to internal reflection during rest, appears to be a marker of healthy cognitive function. Creativity researchers have become particularly interested in the default mode network because of its association with the kinds of cognitive processes that seem relevant to creative thinking. Generating novel ideas, making unexpected connections between concepts, thinking divergently rather than convergently. All of these aspects of creativity seem to benefit from the kind of unconstrained mental exploration that occurs when the default mode network is active. Several studies have found that periods of mind wandering can actually enhance subsequent creative problem solving. Perhaps because the wandering mind makes associations that wouldn't occur during focused, directed thinking. The breakthrough insight that solves a problem often comes not when you're intently focused on it, but rather when you've stepped away and let your mind wander. This has practical implications for how we structure our work and learning. The modern emphasis on constant productivity, on filling every moment with focused activity, may actually be counterproductive for the kinds of creative and integrative thinking that drive innovation. The brain needs downtime, not just sleep, but also wakeful rest periods where the default mode network can do its work of consolidating memories, making connections, and generating insights. The coffee break, the walk without a destination, the commute spent staring out the window, these aren't wasted time. They're opportunities for a different kind of mental processing, one that's essential for learning, creativity, and mental health. The default mode network also plays a crucial role in narrative thinking, our tendency to organize experience into stories with beginnings, middles, and ends. Humans are storytelling creatures. We don't just remember events as isolated facts. We embed them in narratives that give them meaning and connect them to our broader life story. The default mode network appears to be the neural substrate for this narrative processing. When people are asked to recall personal memories or imagine future events, they don't just retrieve or generate isolated images. They construct stories, complete with temporal sequences, causal connections, and emotional significance. This narrative organization of experience is fundamental to human cognition and identity, and it emerges from the brain's default mode of operation. Interestingly, the default mode network may also be involved in processing the boundaries between self and other, between internal mental states and external reality. Studies using psychedelic substances, which profoundly alter consciousness and often produce experiences of ego dissolution or unity with the universe, consistently show reduced activity and connectivity in the default mode network. This finding has led to the hypothesis that the normal functioning of this network maintains the boundaries of the self, the sense of being a separate individual distinct from the environment and other people. When this network's activity is reduced, either through meditation, psychedelic substances, or certain neurological conditions, these boundaries can become permeable or dissolve entirely. The sense of self, it appears, is not a given, but rather something actively constructed and maintained by ongoing neural processing. The development of the default mode network over the lifespan also provides insights into cognitive maturation and aging. In infants and young children, the default mode network is present but not fully formed. The connectivity between its regions strengthens during childhood and adolescence, reaching adult-like patterns in early adulthood. This developmental trajectory parallels the maturation of self-awareness, autobiographical memory, and theory of mind. Young children are famously present-focused, living in the moment rather than extensively planning for the future or dwelling on the past. As the default mode network matures, children gain the capacity for the kind of mental time travel and self-reflection that characterizes adult cognition. This comes with benefits, the ability to learn from the past and plan for the future, but also with costs, the tendency toward worry, rumination, and disconnection from immediate experience. In older adults, the default mode network often shows reduced connectivity and less efficient transitions between default mode and task-positive states. This may contribute to some of the cognitive changes associated with aging, particularly in memory and executive function. However, the changes aren't uniformly negative. Some research suggests that older adults may be better at certain kinds of integrative thinking that draw on accumulated life experience, possibly because their default mode networks have had decades to build rich associative networks of knowledge and experience. The wisdom sometimes attributed to older adults may have a neurological basis in the extensive connectivity of a well-developed default mode network. The relationship between the default mode network and consciousness remains an active area of investigation and debate. Does this network give rise to consciousness, or is it merely one content of consciousness among many? When you're in a dreamless sleep or under general anesthesia, the default mode network shows markedly reduced activity. But is this reduction the cause of unconsciousness or merely a consequence of it? These questions touch on some of the deepest mysteries in neuroscience, the nature of subjective experience, and how it emerges from physical processes in the brain. Some researchers propose that consciousness requires the integration of information across distributed brain networks, and the default mode network, with its extensive connectivity to diverse brain regions, may be crucial for this integration. Others argue that the default mode network is simply one of many networks that can support conscious experience, and that consciousness can persist even when this particular network is inactive. The discovery of the default mode network has also raised questions about the nature of rest and what it means for the brain to be at rest. Traditional definitions of rest as the absence of activity clearly don't apply to the brain. Even during what we call rest, the brain is intensely active, just in different ways than during goal-directed tasks. This realization has led researchers to distinguish between different kinds of rest. There's passive rest, like staring at a blank screen, where the default mode network tends to be highly active. There's active rest, like gentle walking or simple repetitive tasks, where the balance between networks may be different. And there's mindful rest, where attention is directed toward immediate sensory experience, which tends to reduce default mode activity. Each kind of rest may serve different cognitive functions and benefit the brain in different ways. The network's role in processing the past and future also raises interesting questions about the nature of time in consciousness. Physical time flows in one direction, from past to future, but mental time is more flexible. In your mind, you can move freely between past and future, replaying old memories and previewing upcoming events. The default mode network appears to be the neural machinery that allows this mental time travel. But this capacity comes with a cost. While you're mentally inhabiting the past or future, you're to some degree absent from the present. Much of human suffering comes from dwelling on past regrets or worrying about future threats, from being trapped in mental time rather than inhabiting actual time. The default mode network, for all its adaptive value, may also be the source of uniquely human forms of psychological distress. Research has also revealed that the default mode network doesn't operate in isolation, but interacts with many other brain networks. It has extensive connections with the salience network, which helps determine what information is important enough to pay attention to. It interacts with the executive control network, which manages cognitive resources and directs attention. It receives input from sensory regions and sends output to motor regions. The default mode network sits at a kind of hub position in the brain's overall architecture, positioned to integrate information from diverse sources and influence multiple downstream processes. This central position may explain why disruption of this network has such widespread effects on cognition and behavior. One particularly fascinating aspect of default mode network research involves its relationship to sense of agency, the feeling that you are the author of your actions and thoughts. Normally, we experience our thoughts and actions as being generated by ourselves, by the unified agent we identify as I. But various neurological conditions and experimental manipulations can disrupt this sense of agency. People with schizophrenia, for example, sometimes experience their thoughts as being inserted by external forces rather than generated by themselves. Studies suggest that altered connectivity between the default mode network and other brain regions may contribute to these disturbances in agency. The sense that you are the thinker of your thoughts and the doer of your deeds may depend on the proper functioning of this network. The default mode network also appears to play a role in moral judgment and ethical reasoning. When people think about moral dilemmas, particularly those involving personal relationships and social norms, the default mode network activates, along with regions more specifically associated with emotional processing. This makes sense given that much of morality involves understanding others' mental states, imagining different scenarios and their consequences, and evaluating actions in light of social norms and personal values. All of these processes draw on the cognitive capacities supported by the default mode network. Your moral intuitions, your sense of right and wrong, emerge in part from the spontaneous activity of the brain when it's not focused on immediate practical tasks. Recent research has also examined how the default mode network functions during sleep. During non-REM sleep, the network shows reduced activity and connectivity, but during REM sleep, when dreaming is most vivid, parts of the network reactivate. This pattern aligns with the observation that dreams often have a narrative quality and frequently involve social interactions, memories, and self-referential content. Precisely the kinds of cognitive processes associated with default mode function during waking rest. Dreams may be what happens when the default mode network operates, without the constraints normally imposed by sensory input and executive control. The bizarre, illogical quality of dreams may reflect the unconstrained operation of the associative processes that normally help generate creative insights during waking rest. The study of the default mode network has also led to new understanding of attention deficit hyperactivity disorder. People with ADHD often show abnormal patterns of default mode network activity, particularly difficulty suppressing this network during tasks that require external focus. The mind-wandering and distractibility characteristic of ADHD may result from the default mode network intruding into moments that require task-focused attention. This understanding has suggested new approaches to treatment, helping people with ADHD develop better metacognitive awareness of when their minds have wandered and strategies for redirecting attention back to the task at hand. The network's involvement in self-referential processing has also made it relevant to understanding various personality traits and individual differences. People high in neuroticism, for example, tend to show greater default mode activity, particularly in regions associated with negative self-referential thoughts. People high in openness to experience show more flexible coupling between the default mode and executive control networks, which may relate to their greater capacity for creative thinking and imaginative exploration. The baseline activity patterns of your default mode network, something you're not consciously aware of or deliberately controlling, may shape fundamental aspects of your personality and cognitive style. Understanding the default mode network has also influenced education theory and practice. The traditional model of learning emphasizes continuous engagement with material, with students expected to maintain constant focus during class time. But recognition of the importance of rest states and default mode processing suggests that learning actually requires alternation between focused study and periods of rest where the default mode network can consolidate new information and integrate it with existing knowledge. The most effective learning may involve cycles of engagement and disengagement rather than sustained focus. Taking breaks isn't procrastination, but rather an essential part of the learning process. The relationship between the default mode network and language is also intriguing. Language processing typically activates a left-lateralized network of brain regions distinct from the default mode network. However, understanding narratives, following story plots, and comprehending language that describes mental states and social relationships recruits default mode regions alongside traditional language areas. This suggests that language comprehension isn't just about processing words and sentences, but also about constructing mental models of situations and characters, imagining scenarios, and attributing mental states, all processes that depend on the default mode network. When you're absorbed in a good novel, your default mode network is highly active, constructing a rich mental simulation of the story's world and characters. Research has also examined how the default mode network responds to different kinds of stimuli and contexts. Natural environments, for example, seem to have a distinctive effect on default mode activity. Spending time in nature often produces a subjective sense of mental restoration and peace. Brain imaging studies suggest that natural environments may normalize default mode activity. reducing excessive rumination in people prone to it, while maintaining the network's ability to support adaptive reflection and planning. Urban environments, by contrast, place greater demands on directed attention and may reduce the opportunity for the kind of restorative rest that allows healthy default mode function. The social dimension of default mode network function deserves particular emphasis. Humans are intensely social creatures, and much of our mental life involves thinking about social relationships, understanding others' perspectives, navigating social hierarchies, and maintaining our social identity. The default mode network appears to be specialized for precisely these kinds of social cognition. When you're sitting alone with no particular task, your mind naturally gravitates towards social thoughts. Who said what to whom? What does someone think of you? How did that interaction go? What will you say when you see someone next? This constant social processing, occurring automatically whenever the mind is free to wander, reflects the fundamental importance of social relationships to human survival and well-being. The default mode network may have evolved primarily to support social cognition, with other functions like memory consolidation and creativity emerging as secondary benefits. Neuroscientists have also discovered that the default mode network shows interesting patterns during social interaction. When two people engage in natural conversation, their brain activity becomes synchronized, with similar patterns of activity occurring in both brains at similar times. This neural coupling is strongest in the default mode network, suggesting that mutual understanding involves not just processing what the other person is saying, but also entering a shared mental state, aligning your own self-referential and social processing with theirs. True communication may involve a temporary merging of default mode states, a neurological basis for empathy and mutual understanding. The study of the default mode network has also contributed to understanding of substance abuse and addiction. Chronic drug use alters default mode network connectivity, often in ways that persist long after drug use has stopped. These changes may contribute to the persistent cravings and high relapse rates characteristic of addiction. The self-referential processing supported by the default mode network appears to be hijacked by addiction, with drug-related thoughts and memories intruding into consciousness whenever the mind is at rest. Effective treatment for addiction may need to address not just the immediate effects of drugs, but also the long-term changes they produce in the brain's default mode of operation. The network also plays a role in processing reward and motivation, particularly rewards related to social standing and self-concept. When you receive positive feedback about yourself, when you succeed at something important to your identity, when you're praised or recognized, regions of the default mode network activate, along with more traditional reward regions. This suggests that much of human motivation is ultimately about maintaining and enhancing the self that the default mode network represents. We're motivated not just by food, safety, and reproduction, but by anything that validates our self-concept and social identity. The default mode network transforms abstract concepts like status, reputation, and achievement into tangible rewards that guide behavior. Recent technological advances have enabled new ways of studying the default mode network. Techniques like multivoxel pattern analysis and machine learning allow researchers to decode what specific thoughts or memories someone is having based on patterns of default mode activity. This raises both exciting scientific possibilities and concerning ethical questions. If brain activity during rest reveals the content of people's private thoughts and memories, what are the implications for privacy and autonomy? These questions will become increasingly pressing as brain imaging technology continues to advance. The relationship between the default mode network and free will is another deep philosophical question raised by this research. If much of your mental life consists of thoughts that arise spontaneously from the default mode network, thoughts you don't consciously choose to think, then in what sense are you the author of your mental life? The sense of being a unified self with free will may itself be a construction of the default mode network, a story the brain tells itself to create coherence from the parallel, distributed processes actually driving behavior. This doesn't necessarily mean free will is an illusion, but it does suggest that the self who exercises will may be more complex and less unitary than our subjective experience suggests. Looking forward, research on the default mode network continues to evolve. New questions emerge as technologies improve and theoretical frameworks develop. How do different default mode subnetworks interact to produce specific cognitive functions? How plastic is the default mode network, and can it be deliberately modified through training or intervention? How do pharmacological agents affect default mode function, and could drugs be developed to normalize dysfunctional patterns? What can variation in default mode architecture tell us about individual differences in cognition and personality? These questions will occupy researchers for years to come. The discovery and characterization of the default mode network represents one of the most significant advances in cognitive neuroscience of the past several decades. It has fundamentally changed how we think about the brain, shifting from a reactive model where the brain simply responds to stimuli to an intrinsically active model where the brain generates its own internal dynamics even in the absence of external input. The brain is not a passive receiver of information, but an active constructor of experience, constantly generating predictions, simulations, and narratives. The activity that emerges when you have no particular goal may be the brain's most characteristic and important mode of operation, the one that makes us distinctively human. Understanding what the brain does without goals has paradoxically helped us understand how the brain achieves goals. Because those goal-directed processes emerge from and return to the intrinsic dynamics of the default mode network. Your brain's rest state isn't a waiting state. It's a different kind of work, perhaps the most important work of all, the construction and maintenance of the self that experiences and acts in the world. The implications of default mode network research extend into virtually every domain of human experience, from education to mental health to our understanding of what it means to be conscious. Consider how this research changes our understanding of boredom, that seemingly simple state we all experience but rarely examine closely. Boredom isn't just the absence of stimulation or the frustration of having nothing to do. From a neuroscience perspective, boredom may represent a conflict between the default mode network's drive to engage in self-referential processing and environmental constraints that prevent meaningful engagement with either internal or external content. When you're stuck in a tedious meeting or waiting in a long line, your default mode network wants to engage in its typical activities, constructing narratives, planning for the future, replaying memories, but the situation demands a minimal level of external attention that prevents full engagement with either mode. You're caught between worlds, unable to fully attend to the external environment because it's not sufficiently engaging, but also unable to fully withdraw into internal processing because the situation requires some level of alertness. This conflict creates the distinctive, unpleasant feeling of boredom. Research on the default mode network has also illuminated the phenomenon of flow states. Those moments of complete absorption in an activity where time seems to disappear and performance reaches its peak. During flow, people report a loss of self-consciousness, a merging of action and awareness, and complete focus on the present moment. Brain imaging studies during flow states show decreased activity in the medial prefrontal cortex, a key node of the default mode network. The loss of self-consciousness during flow appears to have a neural correlate in the temporary suppression of self-referential processing. When you're completely absorbed in playing music, solving a challenging problem, or engaging in athletic performance, the narrative self constructed by the default mode network temporarily recedes, allowing for a different quality of experience. This finding suggests that peak performance and peak experience may both involve transcending the default mode of self-referential thinking. The network's role in constructing and maintaining identity becomes particularly evident when we consider people who have experienced dramatic life changes or trauma. After traumatic experiences, the default mode network can become stuck replaying traumatic memories, a pattern seen in post-traumatic stress disorder. The spontaneous mental activity that normally supports adaptive reflection and planning, instead, becomes dominated by intrusive memories and threat-related simulations. This suggests that effective treatment for PTSD needs to address not just the memories themselves, but the default mode processes that keep reactivating them during rest. Therapies that help people construct new narratives about traumatic experiences, that integrate trauma into a broader life story rather than letting it dominate the narrative self, may work partly by reorganizing default mode network activity. The relationship between the default mode network and religious or spiritual experience presents another fascinating area of investigation. Many religious practices involve techniques designed to quiet the narrative self, to transcend ordinary ego consciousness and experience something larger or more fundamental. Contemplative prayer, mystical practices, and various forms of meditation all seem to work partly by modulating default mode network activity. Neuroimaging studies of people during prayer or spiritual practices often show altered connectivity within the default mode network, particularly reduced activity in regions associated with self-other boundaries. The mystical experience of unity with the divine, or with all of reality, may involve a temporary dissolution of the neural processes that normally maintain the sense of being a separate self. This doesn't reduce spiritual experience to mere brain activity, but it does provide a neurological framework for understanding how such experiences might arise. Education researchers have become increasingly interested in applying default mode network findings to improve learning outcomes. The traditional classroom model assumes that learning happens primarily during active instruction, when students are focused on the teacher or on learning materials. But understanding the role of the default mode network in memory consolidation and integration suggests that learning also requires periods of rest and reflection. Some educational researchers now advocate for incorporating structured rest periods into the school day, times when students aren't expected to maintain external focus, but can allow their minds to wander and process what they've learned. Early studies suggest that these rest periods can improve retention and understanding, particularly for complex material that requires integration with prior knowledge. The brain needs time to make sense of new information, and that sense-making often happens when students aren't actively studying. The default mode network's role in processing temporal information, in mentally traveling through time, also has implications for understanding how people make decisions and plan for the future. Humans often struggle with delayed gratification, choosing immediate rewards over larger future rewards, a tendency that contributes to everything from financial problems to health issues. Research suggests that the vividness with which people can imagine future scenarios influences their decisions. People who can construct rich, detailed mental simulations of their future selves tend to make more far-sighted choices. Since the default mode network supports this kind of mental simulation, individual differences in default mode function might partially explain differences in future-oriented thinking and planning. Interventions that help people engage in more vivid and detailed future thinking, that strengthen their ability to use their default mode network for prospection, might improve decision-making. The network also plays a crucial role in how we process and recover from daily stress. Modern life involves constant demands on our attention, constant switching between tasks, constant exposure to information and stimulation. This lifestyle leaves little room for the kind of undirected rest that allows healthy default mode function. Some researchers have suggested that many contemporary mental health problems may stem partly from chronic default mode network dysfunction caused by insufficient rest and excessive demands on directed attention. The epidemic of anxiety and depression in modern societies might be partly a consequence of lifestyles that don't allow adequate time for the restorative processes supported by the default mode network. This perspective suggests that addressing mental health at a societal level requires not just better treatment options, but also cultural changes that value rest and create space for the mind to wander. Research on the default mode network has also contributed to our understanding of genius and exceptional creativity. Historical accounts of scientific breakthroughs and artistic innovations often describe them occurring during moments of rest. During walks or baths or idle moments when the thinker wasn't actively working on the problem. The famous story of Archimedes shouting "Eureka!" in the bath, or of Kekulé discovering the structure of benzene while daydreaming about a snake eating its tail, exemplify this pattern. These aren't just anecdotes. They reflect a genuine cognitive phenomenon where the default mode network, freed from the constraints of directed problem solving, can make novel associations and generate insights that elude focused thinking. The most creative individuals may be those who can most effectively harness their default mode network's capacity for associative thinking and integrate those insights with focused analytical work. The study of the default mode network has also informed our understanding of cultural differences in cognition and self-concept. Western cultures tend to emphasize an independent self-concept, viewing the individual as fundamentally separate from others and defined by internal attributes. Eastern cultures more often emphasize an interdependent self-concept, viewing the self as fundamentally connected to others and defined through relationships. Brain imaging studies have found cultural differences in default mode network activity patterns that align with these different self-concepts. People from Western cultures show more activity in regions associated with processing internal attributes when thinking about themselves, while people from Eastern cultures show more activity in regions associated with processing social relationships. The basic architecture of the default mode network is universal, but how it constructs the self appears to be shaped by culture, demonstrating the brain's remarkable plasticity, even in its intrinsic functional organization. The relationship between the default mode network and language acquisition presents another intriguing research direction. Learning a language isn't just about memorizing vocabulary and grammar rules. It requires internalizing a new way of organizing experience, of carving up reality into linguistic categories. Becoming fluent in a language means being able to think in that language, to have internal monologue and self-talk in the new linguistic system. This process appears to involve reorganizing default mode network activity. Proficient bilinguals show different patterns of default mode activity depending on which language context they're in, suggesting that the narrative self constructed by the default mode network can shift between different linguistic frameworks. Language doesn't just allow us to communicate with others, but fundamentally shapes how we think about ourselves and our experiences when alone with our thoughts. The network's involvement in processing value and meaning has implications for understanding existential questions and concerns. Humans uniquely grapple with questions about the meaning and purpose of life, questions that have no obvious survival value and that other animals don't seem to contemplate. These existential concerns appear to emerge from the same default mode processes that support autobiographical memory and future planning. The ability to mentally project yourself into the past and future, to imagine different possible lives, to compare your actual existence with imagined alternatives, inevitably raises questions about why you exist and what gives your life meaning. Existential anxiety, the fear that life might be meaningless or that death renders everything pointless, may be an unavoidable byproduct of having a default mode network sophisticated enough to support complex self-reflection and mental time travel. Philosophy and religion can be understood partly as cultural tools humans have developed to manage the existential concerns generated by their own brain architecture. Research has also examined how the default mode network responds to different types of cognitive challenges. Not all tasks equally suppress default mode activity. Tasks that require pure sensory processing or simple motor responses strongly suppress the network, but tasks that involve understanding narratives, thinking about social relationships, or making meaning of experiences may actually recruit default mode regions even while they also activate task-positive networks. This finding suggests that the boundary between task and rest, between externally directed and internally directed cognition, isn't as sharp as researchers initially thought. Many real-world cognitive activities require integration of external information with internal models and memories, a process that demands coordination between default mode and task-positive networks rather than simple alternation between them. The study of exceptional memory abilities has also provided insights into default mode network function. People with highly superior autobiographical memory, who can recall virtually every day of their lives in extraordinary detail, show distinctive patterns of default mode network connectivity. Their enhanced memory appears to involve not just better encoding or storage, but continuous, spontaneous rehearsal of autobiographical information during rest. Their default mode networks seem to be constantly replaying and organizing memories, creating the rich autobiographical database that allows such detailed recall. However, this ability isn't entirely beneficial. Many people with superior autobiographical memory report being overwhelmed by memories, unable to forget trivial details, and struggling to live in the present because their minds constantly drift to the past. It's a reminder that healthy cognition requires balance, that the default mode network needs to engage in memory processing, but not become dominated by it. The network's role in creative writing and storytelling has attracted attention from literary scholars and cognitive scientists alike. When accomplished writers compose fiction, their default mode networks show robust activity, particularly in regions associated with constructing mental scenarios and attributing mental states to characters. Writing fiction appears to be a kind of controlled daydreaming, using the default mode network's capacity for simulation and narrative construction, but directing it toward a specific creative goal. Writers often report that their characters seem to take on lives of their own, acting in ways the writer didn't consciously plan. This experience may reflect the default mode network generating character behavior through the same processes it uses to predict real people's behavior, creating simulations sufficiently complex that they surprise even the person generating them. Research on the default mode network has also contributed to debates about animal consciousness and cognition. Do other animals have default mode networks? And if so, what does that tell us about their inner lives? Studies have identified default mode-like networks in monkeys, suggesting that at least some aspects of self-referential processing and mental time travel may not be unique to humans. However, the human default mode network appears to have expanded and elaborated substantially during evolution, particularly in regions associated with language and complex social cognition. This expansion may underlie some of the distinctive features of human consciousness: our elaborate sense of self, our ability to construct complex narratives about our lives, our tendency toward existential reflection. Understanding the evolution of the default mode network may help explain how human consciousness emerged from more basic forms of animal awareness. The relationship between the default mode network and music cognition offers another fascinating area of study. Listening to music, particularly music with emotional significance, often activates default mode regions. Music seems to have a special ability to evoke autobiographical memories, to transport listeners to specific times and places in their past. A song associated with a particular period of life can instantly bring back not just memories of events, but the emotional quality of that time, the sense of who you were then. This powerful connection between music and memory appears to involve default mode network regions, particularly those associated with emotional processing and autobiographical recall. Music may provide a kind of direct access to the autobiographical self, bypassing the verbal narrative structures we usually use to organize and communicate our memories. The study of mind wandering, once dismissed as a trivial mental state or simply a failure of attention, has become a major research focus thanks to the discovery of the default mode network. Mind wandering is not a unitary phenomenon, but encompasses various types of off-task thought. Sometimes mind wandering is deliberate, a conscious choice to think about something other than the task at hand. Other times it's spontaneous, with thoughts seeming to arise unbidden. The content of mind wandering varies too, sometimes focused on immediate personal concerns, other times on abstract ideas or creative exploration. What unites these different forms of mind wandering is the involvement of the default mode network. Understanding the neural basis of mind wandering has practical applications for education, workplace productivity, and understanding conditions like ADHD, where mind wandering becomes excessive and uncontrollable. The default mode network's relationship to sleep and dreaming has opened new avenues for sleep research. Dreams during REM sleep often have a narrative structure, involve social interactions, and feature emotional content, all characteristics that align with default mode network function. Some researchers have proposed that dreaming represents a special operating mode, where the default mode network processes emotional experiences and memories without the reality constraints normally imposed by sensory input and executive control. This perspective suggests that dreams aren't just random neural noise, but may serve important functions in emotional regulation and memory consolidation. Functions that require the default mode network to operate in a particular way that's only possible during sleep. Research has also examined how acute and chronic pain affect default mode network function. Chronic pain patients often show altered default mode connectivity and difficulty disengaging from pain-related thoughts even during rest. The constant intrusion of pain into awareness may hijack the default mode network's attention, making it difficult for patients to engage in the normal restorative processes of rest. This finding suggests that effective pain management needs to address not just the sensation of pain, but also its effects on cognitive and emotional processing. Interventions like mindfulness-based stress reduction, which help patients change their relationship to pain and reduce pain-related rumination, may work partly by normalizing default mode network function. The network's involvement in processing reward and motivation has implications for understanding procrastination and self-control failure. When you procrastinate, you're typically choosing an immediately pleasant activity over a more important but less immediately rewarding one. This choice involves a conflict between your current self, represented by present desires and feelings, and your future self, represented by goals and values. The default mode network is involved in representing both of these selves, in imagining your future self and its preferences. People who procrastinate less may have default mode networks that construct more vivid and compelling representations of their future selves, making future consequences feel more real and motivating in the present. Understanding procrastination as partly a failure of future self-representation suggests interventions focused on strengthening people's ability to imagine and care about their future selves. The study of the default mode network has also informed our understanding of hypnosis and suggestibility. Hypnotic states involve altered self-awareness and increased suggestibility, changes that appear to involve modulation of default mode network activity. During hypnosis, activity in the medial prefrontal cortex often decreases, corresponding to reduced self-monitoring and self-consciousness. Highly hypnotizable individuals show distinctive baseline patterns of default mode connectivity, suggesting that susceptibility to hypnosis may reflect stable individual differences in how the default mode network functions. Understanding hypnosis in terms of default mode network modulation provides a neurological framework for a phenomenon that has long seemed mysterious. Research on the default mode network has also contributed to understanding of dissociative disorders, conditions where people experience disconnections between thoughts, memories, feelings, actions, or sense of identity. Dissociative identity disorder, formerly called multiple personality disorder, involves the presence of two or more distinct personality states, each with its own pattern of perceiving and relating to the world. Brain imaging studies have found that different personality states in the same individual show different patterns of default mode network activity, as if each state involves a different configuration of the neural processes that construct the self. This finding suggests that the unified sense of identity most people experience isn't inevitable, but rather depends on the integration of default mode network processes. Integration that can be disrupted by trauma or other factors. The network's role in processing fairness and justice has attracted attention from researchers studying moral cognition and social behavior. Humans have strong intuitions about fairness that go beyond simple self-interest. People will often sacrifice their own resources to punish unfairness or to help others, behaviors that don't make sense from a purely selfish perspective. These fairness concerns appear to involve default mode regions, particularly those associated with social cognition and self-referential processing. Understanding fairness involves simulating others' perspectives, imagining how they experience situations, and evaluating actions against internalized social norms. All of these processes rely on default mode network function. Individual differences in default mode connectivity may partially explain differences in moral intuitions and social behaviors. The study of the default mode network has implications for artificial intelligence and machine learning as well. Current AI systems are primarily reactive, processing inputs and generating outputs without any internal life or spontaneous mental activity when not engaged with tasks. Some AI researchers have suggested that achieving more human-like artificial intelligence might require implementing something analogous to a default mode network, a system that continues to process information, consolidate learning, and generate predictions even when not responding to immediate queries. This isn't just a technical challenge, but raises philosophical questions about whether spontaneous internal activity is necessary for consciousness or genuine intelligence. Research has also examined how the default mode network changes in response to major life transitions. Events like becoming a parent, retiring from work, or losing a spouse all involve reorganizing one's sense of self and life narrative. These transitions appear to involve substantial reorganization of default mode network activity as people construct new identities and integrate changed circumstances into their life stories. The difficulty of major life transitions may partly reflect the challenge of reorganizing the neural processes that construct and maintain identity. Support systems that help people process and make sense of transitions, that facilitate the construction of new narratives, may work partly by supporting healthy reorganization of default mode function. The relationship between the default mode network and emotion regulation has important implications for mental health. Emotion regulation involves not just suppressing or expressing emotions, but making sense of them, understanding their causes, and integrating emotional experiences into your broader self-understanding. These processes recruit default mode regions, along with areas more specifically involved in emotional processing. People who are better at emotion regulation show more effective coordination between default mode and emotion processing regions. They're able to reflect on their emotions, to construct narratives about why they feel the way they do, without becoming overwhelmed by the emotions themselves. Difficulties with emotion regulation, common in many mental health conditions, may involve problems with this coordination. The network's involvement in processing identity and self-concept has implications for understanding identity development during adolescence. Adolescence involves substantial reorganization of self-concept, as young people develop more complex understandings of who they are, what they value, and how they relate to others. This period of identity formation appears to involve continued maturation and reorganization of default mode network connectivity. The identity exploration and sometimes instability characteristic of adolescence may reflect the brain's ongoing refinement of the neural processes that construct and maintain a stable sense of self. Understanding adolescent development as partly a process of default mode network maturation can help explain both the challenges of this period and its importance for establishing adult identity. Research has also examined how different forms of psychotherapy may work through effects on the default mode network. Psychoanalytic therapy, with its emphasis on free association and exploring unconscious thoughts, may work partly by helping patients become more aware of and gain insight into their default mode processing. Cognitive behavioral therapy, which focuses on identifying and changing maladaptive thought patterns, may help patients gain better control over default mode activity and reduce rumination. Narrative therapy, which emphasizes reconstructing life stories, directly engages the default mode network's narrative functions. Different therapeutic approaches may work through different mechanisms, but many appear to involve helping patients change how their default mode networks function. Whether through increased awareness, better regulation, or reorganization of narrative frameworks. The study of the default mode network has also illuminated the phenomenon of nostalgia, that bittersweet longing for the past. Nostalgia isn't just remembering past events, but involves a particular emotional tone, a sense of yearning mixed with pleasure, often triggered by sensory cues like music or smells. Brain imaging studies show that nostalgic remembering activates default mode regions, along with reward and emotion processing areas. Nostalgia may serve important psychological functions, providing continuity of self across time, offering comfort during difficult periods, and strengthening social bonds through shared memories. The default mode network's tendency to spontaneously replay positive autobiographical memories may have evolved partly to maintain psychological well-being through nostalgic remembering. The network's role in imaginative play and pretense, particularly in childhood, has attracted attention from developmental psychologists. Young children spend substantial time engaged in pretend play, creating imaginary scenarios and characters. This play appears to involve early recruitment of default mode network regions, as children practice using their simulation capacities for creative purposes. Pretend play may help develop the default mode network's capabilities, strengthening children's abilities to imagine alternative scenarios, understand others' perspectives, and engage in creative thinking. Individual differences in childhood engagement with imaginative play may predict later differences in default mode network function and related cognitive abilities. Research has also examined how the default mode network responds to mindfulness training over time. Long-term meditators show not just reduced default mode activity during meditation, but also changed baseline patterns of connectivity even during rest. The network becomes less densely connected, particularly in regions associated with rumination and self-focused thought. These changes correlate with meditators' reports of reduced mind wandering, less tendency toward negative self-focused thinking, and greater present moment awareness. Mindfulness training appears to produce lasting changes in the brain's default mode of operation, changes that persist even when not actively meditating. The study of the default mode network has implications for understanding grief and bereavement. Losing someone close often involves a prolonged period of grief, during which thoughts of the deceased person intrude frequently into consciousness. The default mode network appears to be involved in this process, spontaneously activating memories of the deceased and simulating interactions that can no longer occur. Complicated grief, where the grieving process becomes stuck and doesn't resolve over time, may involve the default mode network becoming excessively focused on the deceased person, unable to reorganize the narrative self to accommodate the loss. Effective grief therapy may work partly by helping the default mode network construct new narratives that integrate the loss while allowing continued connection to the deceased person's memory. The relationship between the default mode network and aesthetic experience, the appreciation of beauty in art and nature, offers another fascinating research direction. When people view paintings or listen to music they find beautiful, default mode regions activate along with sensory and emotional areas. Aesthetic experience appears to involve not just processing sensory features, but also self-referential processing, connecting the artwork to personal memories and meanings. The default mode network may be where subjective aesthetic experience arises, where sensory information is integrated with personal significance to create the feeling that something is beautiful or meaningful. Individual differences in aesthetic sensitivity may reflect differences in how readily the default mode network engages with aesthetic stimuli. Research has also examined how cultural practices and traditions shape default mode network function across the lifespan. Cultures differ in their typical activities during rest, in their attitudes toward mind-wandering and daydreaming, in their practices for reflection and contemplation. These cultural differences appear to produce differences in default mode network organization and function. Cultures that emphasize contemplative practices may produce individuals whose default mode networks function differently from those in cultures that emphasize constant activity and productivity. Understanding these cultural differences can help us appreciate that there isn't one ideal way for the default mode network to function, but rather multiple ways shaped by cultural values and practices. The network's involvement in humor comprehension and appreciation has also attracted research attention. Getting a joke often involves understanding implicit meanings, making unexpected connections, and appreciating incongruity, processes that recruit default mode regions. The pleasure of humor may partly come from the default mode network successfully making connections that initially seemed impossible, from the surprise of seeing how disparate elements fit together. Individual differences in sense of humor may reflect differences in default mode network function, particularly in the flexibility with which the network can make novel associations and find meaning in unexpected juxtapositions. The study of the default mode network continues to evolve and expand, opening new questions even as it answers old ones. Each discovery reveals new layers of complexity in how the brain constructs experience and maintains the self. Understanding what the brain does without goals has become central to understanding how the brain functions with goals, because those directed activities emerge from and return to the intrinsic dynamics of the resting brain. The default mode network represents the brain's baseline state, the canvas on which all other activities are painted. It is where the self resides when not engaged with the world, where memories are consolidated and futures imagined, where meaning is made and narratives constructed. This network, active precisely when we think we're doing nothing, may be doing the most important work of all, the work of being human. The exploration of default mode network function has also led researchers to reconsider fundamental assumptions about attention and consciousness. Traditional models portrayed attention as a spotlight that illuminates specific aspects of experience while leaving everything else in darkness. The default mode network reveals this model to be incomplete. Even when your attention is focused externally, the default mode network continues operating in the background, maintaining your sense of self, your autobiographical context, your social awareness. Attention doesn't turn off self-referential processing, but rather modulates it, adjusting the balance between internal and external focus. This finding suggests that consciousness isn't a single unified state, but rather involves multiple parallel streams of processing that can be coordinated in various ways depending on task demands and internal states. The network's role in maintaining what psychologists call the continuity of self across time has profound implications for understanding personal identity. You experience yourself as the same person you were yesterday and expect to be tomorrow, despite the fact that your body's cells are constantly being replaced. Your memories are constantly being updated, and your circumstances are constantly changing. This sense of continuity appears to depend critically on default mode network function. The network weaves memories, present experiences, and imagined futures into a coherent narrative that creates the experience of being a single person persisting through time. Damage to key nodes of the network can disrupt this continuity, leaving people feeling disconnected from their past selves or unable to imagine their future selves. The self that feels so immediate and obvious, so undeniably real, is actually an ongoing construction project, a story the default mode network tells and constantly revises. Research on the default mode network has also illuminated the relationship between mind and body, particularly how the brain represents bodily states and integrates them into conscious experience. The network has extensive connections to regions that process signals from the body, information about heart rate, breathing, gut sensations, muscle tension, and other physiological states. This integration of bodily information into default mode processing helps explain why physical states so profoundly influence mood and thought patterns. When you're physically tense, your default mode network incorporates that tension into its ongoing self-representation, potentially triggering worry or rumination. When you're physically relaxed, that relaxation influences the quality of self-referential thought. Mind-body practices like yoga or Tai may work partly by changing the bodily signals being integrated into default mode processing, creating conditions for more peaceful and less anxious self-referential thought. The study of extreme environments and situations has provided natural experiments for understanding default mode network function. Research on astronauts during long-duration spaceflight, for example, has revealed how the profound isolation and unchanging environment of space affects default mode activity. Without the usual variety of social interactions and environmental stimuli that normally trigger different patterns of self-referential thought, astronauts report changes in how they experience themselves and their relationships. The default mode network appears to need a certain richness of experience to function optimally. Too little stimulation can lead to a narrowing of self-concept and difficulty maintaining normal patterns of thought. These findings have implications not just for space exploration, but for understanding how isolation affects people in other contexts, from solitary confinement to extended periods of social isolation. The relationship between the default mode network and peak experiences, those moments of profound joy, connection, or transcendence that people describe as among the most meaningful in their lives, remains somewhat mysterious, but increasingly tractable to scientific study. Many peak experiences involve a sense of ego dissolution, of boundaries between self and world becoming permeable or disappearing entirely. The default mode network, which normally maintains those boundaries, shows altered activity during such experiences. Whether triggered by meditation, psychedelic substances, extreme athletic exertion, or spontaneous mystical experiences, peak experiences often involve a temporary reorganization of default mode function. Understanding the neuroscience of these experiences doesn't diminish their significance, but may help us understand why they're so transformative and how they produce lasting changes in people's perspectives and values. Research has also examined how the default mode network processes counterfactual thinking, imagining how things could have been different. When you think, if only I had made a different choice, or what if things had gone differently, you're engaging in counterfactual simulation, mentally constructing alternative versions of events. This capacity appears to depend heavily on default mode regions, particularly those involved in episodic memory and future simulation. Counterfactual thinking serves important functions, helping us learn from mistakes and prepare for future decisions by imagining alternative scenarios. However, excessive counterfactual thinking, constantly dwelling on how things could have been different, can contribute to regret, rumination, and depression. The same neural machinery that enables adaptive learning from experience can produce maladaptive patterns of thought when it becomes dysregulated. The network's involvement in processing uncertainty and ambiguity has implications for understanding anxiety and decision-making. Life constantly presents situations with uncertain outcomes, ambiguous information, and unpredictable consequences. The default mode network appears to be involved in generating and evaluating possible scenarios when facing uncertainty. People with anxiety disorders often show hyperactivity in default mode regions during uncertain situations, generating an excessive number of possible negative outcomes and having difficulty settling on any particular interpretation or course of action. Understanding anxiety as partly involving dysregulated default mode responses to uncertainty suggests interventions that help people tolerate ambiguity and limit the generation of catastrophic scenarios. The study of the default mode network has also contributed to understanding of wisdom, that elusive quality that goes beyond mere knowledge or intelligence. Wise individuals are characterized by their ability to take broad perspectives, to see situations from multiple viewpoints, to integrate knowledge with emotional understanding, and to make sound judgments in complex situations. Research suggests that wisdom may involve particularly well-developed and flexible default mode network function, allowing wise individuals to draw on extensive life experience, simulate multiple perspectives, and integrate different considerations into coherent judgments. The default mode network's capacity for perspective taking, memory integration, and narrative construction may be the neural foundation for wisdom. Cultivating wisdom may involve not just accumulating knowledge, but developing the default mode network's capacities through reflection, perspective taking, and integration of diverse experiences. Research on the default mode network has implications for understanding how humans process and create meaning. Humans have a profound need to find meaning in their experiences, to understand why things happen and how events fit into larger patterns. This meaning-making appears to be a core function of the default mode network. When events occur, particularly unexpected or emotionally significant events, the default mode network works to integrate them into your existing narrative framework, to make sense of them in terms of your ongoing life story. Sometimes this meaning-making is adaptive, helping you learn from experiences and maintain coherent self-understanding. Other times it can be problematic, as when people construct conspiracy theories or develop paranoid interpretations to explain ambiguous events. The drive to find meaning, even when none may exist, appears to be a fundamental feature of default mode network operation. The relationship between the default mode network and implicit learning, the acquisition of knowledge without conscious awareness, has attracted research attention. While much default mode research focuses on conscious, self-referential thought, the network also appears to support implicit learning processes. When you gradually get better at predicting patterns in the environment, develop intuitions about social situations, or acquire procedural knowledge without explicit instruction, the default mode network may be involved in consolidating these implicit learnings during rest. The network's activity during sleep and wakeful rest may serve to extract regularities from experience and integrate them into your knowledge base, supporting learning that occurs outside of conscious awareness. The study of the default mode network has also illuminated how people process their own mortality and cope with death anxiety. Ernest Becker famously argued that much of human behavior is driven by unconscious awareness of mortality and efforts to achieve symbolic immortality. The default mode network, with its capacity to mentally project into the future and imagine scenarios including one's own death, may be the neural basis for death awareness and the anxiety it produces. However, the network also supports the psychological defenses and meaning-making frameworks that help people cope with mortality awareness. Religious beliefs, legacy concerns, connections to things larger than oneself, all of these ways of addressing mortality involve default mode processes. Understanding how the default mode network processes death-related thoughts may help us understand both death anxiety and the psychological mechanisms people use to manage it. Research has examined how different personality dimensions relate to default mode network function. The Big Five personality traits, openness, conscientiousness, extroversion, agreeableness, and neuroticism, all show associations with different aspects of default mode activity and connectivity. Highly open individuals show more flexible coupling between the default mode and executive control networks, potentially explaining their greater creativity and interest in novel experiences. Highly neurotic individuals show greater default mode activity in regions associated with negative self-referential thought and threat monitoring. Extroverted individuals show different patterns of default mode activity during social cognition compared to introverts. These associations suggest that personality traits, typically described in terms of behavior and experience, have neural correlates in the organization and function of the default mode network. The network's role in processing expectations and prediction errors has implications for understanding learning and adaptation. The brain is fundamentally a prediction machine, constantly generating expectations about what will happen next and updating its models when predictions are violated. The default mode network appears to be involved in generating these predictions, particularly for complex social and autobiographical domains. When you interact with someone, your default mode network predicts how they'll respond based on your prior experiences and knowledge of that person. When they respond differently than expected, a prediction error signal helps update your model of that person. This predictive processing may be a fundamental aspect of how the default mode network supports learning and adaptation in complex, uncertain environments. Research on the default mode network has also contributed to understanding of imposter syndrome, the persistent belief that one's success is undeserved and that one will eventually be exposed as a fraud. People experiencing imposter syndrome show distinctive patterns of self-referential thought, constantly comparing their internal experience of struggle and uncertainty to their perception of others' competence and confidence. This comparison process involves default mode regions, constructing narratives about oneself and others that maintain the belief in one's fraudulence despite objective evidence of competence. The default mode network's role in social comparison and self-evaluation appears central to maintaining imposter syndrome. Interventions that help people recognize these thought patterns and construct alternative narratives may work partly by reorganizing default mode processing. The study of the default mode network has implications for understanding how people process privilege and social inequality. Recognizing one's own privilege, whether based on race, class, gender, or other dimensions, requires comparing one's own experience to others' experiences and understanding how social systems create unequal outcomes. This perspective-taking and comparative processing involves default mode regions. Research suggests that people vary considerably in their ability or willingness to engage in this kind of reflection, and these differences may relate to default mode network function. Some individuals show greater activation of default mode regions when confronted with information about inequality, suggesting engagement with the material, while others show less activation, potentially reflecting defensive avoidance or difficulty with perspective-taking. The network's involvement in processing, regret, and learning from mistakes has attracted attention from researchers studying decision-making and emotional processing. Regret involves counterfactual thinking, imagining how different choices would have led to better outcomes, combined with negative emotion about one's actual choice. This process clearly involves default mode regions, which support counterfactual simulation. However, the intensity and persistence of regret varies substantially across individuals. Some people learn from mistakes and move on, while others become trapped in rumination about past decisions. These differences appear to relate to how the default mode network processes regret, whether it supports adaptive learning or maladaptive rumination. Understanding the neural basis of regret processing may help develop interventions for people who struggle with excessive regret. Research has also examined how the default mode network processes hope and optimism about the future. Hope involves more than just expecting positive outcomes. It involves believing that positive outcomes are possible and that one has some agency in bringing them about. This belief appears to involve default mode regions that support future simulation and self-efficacy judgments. People who maintain hope, even in difficult circumstances, show patterns of default mode activity that may reflect continued generation of positive future scenarios and pathways to achieving them. Understanding hope as involving particular patterns of default mode function may help explain both individual resilience and vulnerability to hopelessness and depression. The study of the default mode network has contributed to understanding of attachment styles and their origins in early relationship experiences. Attachment theory proposes that early experiences with caregivers shape internal working models of relationships that influence social behavior throughout life. These working models appear to involve default mode network representations. Securely attached individuals show patterns of default mode activity during social cognition that differ from those with insecure attachment styles. Insecurely attached individuals may show hyperactivation of default mode regions when processing relationship threats or greater difficulty, regulating negative self-referential thoughts triggered by social situations. Early experiences may literally shape the organization of the default mode network, creating lasting patterns of social cognition and self-representation. Research on the default mode network has implications for understanding procrastination and time management. Procrastination often involves a failure to adequately weight future consequences against present temptations. This involves a conflict between your current self and your future self, both represented by the default mode network. People who procrastinate more may have default mode networks that construct less vivid or less emotionally compelling representations of their future selves, making future consequences feel abstract and unreal. Interventions that strengthen people's connection to their future selves, perhaps through detailed mental simulation or visual representation, may help reduce procrastination by making the future self more salient in default mode processing. The network's role in processing fairness violations and moral outrage has attracted attention from researchers studying moral psychology and political behavior. Humans respond strongly to perceived unfairness, often with anger and desire to punish violators even at personal cost. These responses involve default mode regions, along with emotion and reward areas. Moral outrage appears to involve representing the violated norm, simulating the victim's experience, and evaluating the violator's mental state, all processes that recruit the default mode network. Individual and cultural differences in what triggers moral outrage may reflect differences in the norms represented in default mode networks and the readiness with which violations activate strong emotional responses. The study of the default mode network has also illuminated how people process compliments and praise. Receiving genuine praise activates default mode regions, particularly those involved in self-referential processing and reward. The pleasure of praise comes partly from incorporating positive information into your self-concept, updating the narrative self maintained by the default mode network. However, people vary in their ability to receive and integrate positive feedback. Those with low self-esteem or depression often show reduced default mode responses to praise or even find praise aversive because it conflicts with their negative self-concepts. Psychotherapy aimed at improving self-esteem may work partly by helping people's default mode networks more effectively incorporate positive feedback. Research has examined how the default mode network processes betrayal and trust violations. Being betrayed by someone you trusted activates default mode regions as you try to make sense of the betrayal, reassess your understanding of the person, and update your beliefs about whom you can trust. The intensity of betrayal's impact may relate to how extensively the betrayed person is represented in your default mode network. Betrayal by someone central to your identity and life narrative is more devastating than betrayal by an acquaintance because it requires more extensive reorganization of default mode representations. Recovery from betrayal appears to involve gradually reorganizing these representations, constructing new narratives that accommodate the betrayal while preserving trust in others more generally. The network's involvement in processing forgiveness, both of others and oneself, has implications for understanding emotional healing and psychological well-being. Forgiveness involves letting go of resentment and negative judgments, while often maintaining realistic understanding of what happened. This process appears to involve reorganizing default mode representations of the transgressor, constructing narratives that explain their behavior in less malicious terms, or that emphasize their positive qualities alongside their transgressions. Self-forgiveness involves similar processes, reorganizing harsh self-judgments into more compassionate self-understanding. The difficulty of forgiveness may partly reflect the challenge of reorganizing well-established patterns of default mode network activity. The study of the default mode network continues to raise profound questions about the nature of self and consciousness that extend beyond neuroscience into philosophy and contemplative traditions. If the self is constructed by default mode network activity, then what happens to the self when this activity changes dramatically? Experienced meditators report that intensive practice can lead to experiences where the sense of being a separate self temporarily dissolves, replaced by a sense of awareness without a subject. These reports align with brain imaging findings of greatly reduced default mode activity during deep meditation states. Such experiences suggest that the self we normally take for granted, the unified I, that seems to be the unchanging subject of experience, may actually be a construction that can be deconstructed through particular mental practices. This doesn't mean the self is an illusion, but it does suggest that selfhood is more fluid and contingent than ordinary experience suggests. Research on the default mode network has implications for how we think about free will and moral responsibility. If much of our mental life consists of thoughts that arise spontaneously from default mode network activity, thoughts we don't consciously choose, then our sense of being the conscious author of our thoughts may be partly illusory. Yet we hold people responsible for their thoughts and the actions that follow from them. Understanding that default mode activity generates much of our mental content doesn't eliminate responsibility, but it does complicate traditional notions of free will. Perhaps responsibility lies not in consciously generating each thought, but in how we relate to and respond to the thoughts that arise spontaneously. Mindfulness practices that increase awareness of default mode processes may enhance this kind of metacognitive responsibility. The discovery and ongoing study of the default mode network represents one of neuroscience's most significant achievements, fundamentally transforming our understanding of brain organization and function. What began as a puzzling observation about brain energy use has blossomed into a comprehensive research program that touches on virtually every aspect of human cognition and experience. The default mode network reveals that the brain is not primarily a reactive system that responds to environmental demands, but rather an intrinsically active system that generates its own internal dynamics. These dynamics, far from being mere noise to be filtered out, constitute some of the brain's most important and characteristically human functions, maintaining selfhood across time. Learning from the past, preparing for the future, understanding others' minds, finding meaning in experience, and constructing the narrative that gives coherence to life. Understanding what the brain does without goals has paradoxically helped us understand how brains pursue goals. Because goal-directed behavior emerges from and returns to the intrinsic dynamics of the resting brain. The default mode network is not separate from but intimately connected to all other aspects of brain function. It provides the context within which perception and action occur, the autobiographical and social framework that gives meaning to experience. When you pursue a goal, you do so as someone, a person with a history and a future, with relationships and values, with an ongoing narrative into which this goal fits. All of that context comes from the default mode network. The research also reveals something profound about rest and what it means to do nothing. True rest, it turns out, is impossible for the human brain. Even in the absence of external tasks, the brain remains intensely active, engaged in processes essential for healthy psychological function. The modern tendency to view rest as wasted time, to fill every moment with productivity and stimulation, ignores the fundamental biology of how brains work. The default mode network needs time to operate, to consolidate memories, to process experiences, to maintain the self. Denying the brain this time may have real costs for learning, creativity, emotional health, and well-being. Perhaps the most practical implication of default mode network research is the simplest. Rest matters, not despite, but because of what the brain does during rest. As research continues to advance, the default mode network will undoubtedly reveal more of its secrets. New questions emerge constantly. How do different neurotransmitter systems modulate default mode function? How do hormonal changes across the lifespan affect the network? Can we develop interventions that specifically target problematic patterns of default mode activity? How does the default mode network interact with other recently discovered brain networks? What can we learn from individual differences in network organization? Each answer raises new questions, pushing the boundaries of understanding ever outward. The study of what the brain does without goals has become one of neuroscience's most active and fruitful research programs. One that promises to continue yielding insights into the nature of human consciousness, cognition, and experience for decades to come. The default mode network, that system which becomes most active when you think you're doing nothing, may hold the key to understanding what makes us human.